When specifying filtration systems for oil and gas operations, discussions heavily focus on nominal and absolute micron ratings, assuming a finer rate automatically equates to superior protection. This treats a filter as a static mesh operating under pristine laboratory conditions, overlooking how it holds up against the brutal physical realities of a live processing line. But in actual production loops, fluid streams are rarely steady or uniform. If the underlying filter media lacks structural stability, its nominal micron rating only exists on paper. Under operational stress, geometric pore spacing easily distorts, turning a nominal 10 micron filter into a dynamic, unpredictable barrier that allows highly damaging, oversized particulates to pass straight through the system. Oilfield fluid streams are an incredibly volatile environment for filters. Production and transport loops manage highly unpredictable mixtures, where a single filtration point simultaneously processes high viscosity crude oil, corrosive product water, abrasive sand, and aggressive chemical additives. Managing these streams requires a firm grasp on the physics of solid liquid filtration to ensure continuous particle separation without fouling. This constant variability makes maintaining steady state separation performance incredibly difficult, as fluid characteristics change rapidly and without warning. Viscosity spikes increase shear stress on the filter face, while sudden surges in solid particulate loading form dense, irregular filter cakes that restrict fluid passage and accelerate contaminant accumulation. Consequently, operators must monitor and minimize pressure drop before high resistance triggers a safety trip. Relying on standard filter elements in these environments creates a severe operational risk. To achieve true process control, engineers must look past laboratory data sheets and select filtration media that adapts to changing fluid compositions without shedding captured contaminants or allowing particulate bypass. In an oil and gas facility, fluid pressure is never static. Downstream pump cycling, control valve operation, and equipment backwashing create continuous pressure fluctuations. These cyclical hydraulic shocks travel upstream, placing immense mechanical stress directly onto the filtration element. When exposed to these fluctuations, standard unreinforced mesh or flexible cartridge filters suffer from pore migration. Because fibers are held together only by loose mechanical tension, intense hydraulic forces physically push them apart. This distorts geometry through pore stretching, where individual openings flex and widen past their rated micron size during peak surges, allowing large particulates downstream. It also causes mechanical fatigue, as constant shifting leads to permanent deformation and premature blinding, or broken wire along key stress points. Consequently, a standard filter's rating is completely compromised during pressure spikes, precisely when downstream compressors, catalysts, and injection pumps need protection most. To eliminate structural vulnerabilities under hydraulic shock, Havre and Boker engineered POROSTAR is a multi-layer diffusion bonded wire mesh laminate designed for severe service. Unlike standard woven wire elements, POROSTAR permanently fuses multiple layers of precision wire cloth together at their microscopic intersections using high temperature vacuum sintering. This process creates an unyielding, monolithic porous matrix that preserves absolute pore consistency under demanding conditions. The architecture prevents pore migration because every wire intersection is welded at the molecular level, mechanically locking pore apertures in place even during extreme differential pressure spikes. Additionally, its optimized multi-layer design combines fine filtration layers with rigid drainage and support mesh, providing incredible mechanical strength that prevents the media from buckling or collapsing under severe hydraulic stress. The resulting non-deformable pore paths ensure predictable flow characteristics and uniform fluid distribution across the filter face, keeping system back pressure predictable and maximizing throughput. By providing a rigid interface, POROSTAR eliminates structural failures, maintaining exact separation efficiency under operational stress to protect vital downstream assets and keep the process running smoothly. Thanks so much for watching. If you have any questions, click on our Talk to Us button to get in contact with our many experts on woven wire mesh. And if you'd like to learn more about woven wire mesh or our many products, we have a learning center filled with written and video content to make you an expert. We also have a YouTube channel. And don't forget to click that subscribe button and ring that bell to keep up with all things Havre and Boker. Once again, my name is Andrew Kotlar, and I'll see you around in the next video. Bye for now.